All right, I'm just going to come in and debug this Lambda function that I need to debug. Scroll down and have a look at what's going on here. Wait, what's that? .NET 8 runtime for Lambda? Whoa, it's now available. Yes, that's right. The .NET 8 managed runtime for AWS Lambda is here. It's available for you to use now. And in this video today, you're going to learn how you can take an existing .NET 6 Lambda project and bump that up to .NET 8. And honestly, it's pretty easy to do. Hello architects and developers, and welcome to another video on building serverless applications on AWS. And let's get straight into how this upgrade process actually works. And let's start with the AWS Lambda.NET Handler Cookbook, a repository I've got on GitHub to cover all the best practices for building serverless applications on .NET. Application code, I look at my CS proj, you can see that this is .NET 7. This was using native AOT, so I compiled that with .NET 7. And if I look at my more traditional Lambda function that's using the managed runtime, that is actually using .NET 6. So there's a combination of .NET 6 going on here for the managed runtime and .NET 7 because it already uses native AOT in some places. How do you actually upgrade this to .NET 8? Well, the first thing I'm going to do is come over to this search window on the side, and I want to search for all net 6.0 strings across my entire project. And really simply, I'm just going to change all of them to net 8.0. So now I've bumped every single CS proj file across my entire solution to .NET 8. And remember, I also had the .NET 7 one there because we can still do native AOT in .NET 8. Let's bump that as well. So now every single project file across my entire application is using .NET 8. Perfect. If I now jump over to Rider, let's have a look at some other changes I need to make. So this application uses the AWS CDK as the deployment mechanism, so I'm going to need to bump my CDK code. I've got this shared Lambda function construct to centralize how all my Lambda functions are configured, and the next thing I'm going to do is switch my runtime to .NET. Wait a minute, .NET 8 isn't there. How weird. That's because you're going to need to bump your CDK version. So make sure you're using the latest version of the AWS CDK, both in the NuGet package and also the actual CLI itself, and you'll see that that runtime .NET 8 is now happy and available. So let's bump both of them functions to .NET 8. There's a reason there's an if statement here, is to actually support the fact that native AOT needs a handler named Bootstrap. But actually, you don't really need to do this anymore. Actually, you can use the name of your actual assembly because you're using the managed runtime now, not a custom runtime. You don't need to use Bootstrap as the name of your assembly. You can use the name of your assembly as the actual name of your assembly. And that is really all there is to upgrading to .NET 8. You bump the project versions, update your CDK code. If you're using SAM or you're using the .NET CLI, you equally will need to change that from .NET 6 to .NET 8. And that is now good to go. One of the other really cool things that this unlocks now is with the ability to run ASP.NET on Lambda. Because Microsoft have now released limited support for natively compiling ASP.NET applications, you can now leverage that within AWS Lambda. So within the project, you will notice that there is an AOT ASP.NET project underneath the stock price service. You'll see that in GitHub. The link is in the description. And if you have a look at the program.cs file, you see I'm using this create slim builder function. So if you're using native AOT and ASP.NET, you need to use this create slim builder as opposed to the create builder, which is what you might be familiar with. This create slim builder is just a cut down version of ASP.NET at the startup to make sure that the stuff you're using is the stuff that's actually supported for native AOT. I'm configuring a custom serializer. I'm passing my custom serialization context into my ASP.NET application because remember, you need to be using source-generated serializers to use ASP.NET and native AOT. I'm adding the AWS Lambda hosting using the Amazon Lambda ASP.NET Core Server NuGet package. If you're doing that today, you will need to add this options override and pass in a custom serializer. This tells the AWS Lambda hosting package to use source-generated serializers instead of the default serializer. And now this application is ready to run on Lambda. You've got ASP.NET, you can natively compile that, you have some limited support from Microsoft, and then you can run that inside the context of Lambda. So let's actually deploy this now and see what happens. That has fully deployed now. If you look at the GitHub repo, it's fully GitHub Actions enabled. So I use the CI/CD pipelines to push out the new versions of these applications and then use the tests that I have to actually test that this works. And it's all working. So what I've just done is redeployed all of my Lambda functions so we can see how this actually performs. So here are all the different endpoints I have on my API. If I try and get the stock price, you see that responds 800 milliseconds, not bad. If I try and add a new stock price for the AMZ stock, you've got a little bit of a slower response there. This is not using native AOT, this post endpoint. Remember, this is just using the standard .NET 8 managed runtime, and I'll come back to that performance in just a few seconds. And then finally, you've got the natively compiled ASP.NET endpoint that returned in 700 milliseconds. Again, this is just a string response. It's not actually doing anything functional, but it does respond really quickly. This is natively compiled ASP.NET running inside Lambda, all with the .NET 8 managed runtime now available on Lambda. Now, one thing to bear in mind with all of this, particularly with that post endpoint that you just saw that had a 2.5 second response time, you might think initially, well, .NET 6 responded quicker than that. But one of the things to bear in mind with Lambda is when these new managed runtimes get pushed out, they typically are receiving less usage than existing runtimes. And this can give you slightly longer cold start times. That's because of how the cache residency works inside Lambda's internal systems. So because .NET 8 has only released today, you might initially see slightly slower cold start times than if you were using .NET 6. But don't worry about that. This will typically improve in the coming weeks, in the weeks ahead, as more and more people start to adopt .NET 8, as more of you upgrade your Lambda functions to leverage all the new features of .NET 8, you will then start to see them cold start times come down again. So give it a few weeks and then start to have a look at how your performance works. And that is really all there is to it. One of the amazing things Microsoft have done with .NET is to make jumping from version to version really easy. Backwards compatibility is typically almost always there. So bump your target framework version, update your infrastructure as code, and get building with .NET 8. Enjoy.